This video will be the basic definition of correlation and talk a little bit about a correlation relationship. All right, so the definition first off, statistical method used to determine whether a relationship exists. And now the next sentence there in bold is crucial. If you don't remember anything else from chapter 10, remember this. Note that correlation does not necessarily imply causation. There are actually 5 different possible explanations. We'll get to those in a minute, but to kind of hammer home that point that correlation does not necessarily imply causation, I'm going to give you an example, and this example actually comes out of the CM305 book by Agresti and Franklin, and you can see the complete citation for that in the class notes. They looked at a study from the Gold Coast of Australia that showed a significantly positive correlation between the sales of ice cream per month and the deaths by drowning per month at Australia's Gold Coast. Now, you look at that. Statistically significant correlation between those two things. Now, I don't think too many people are going to argue that consuming more ice cream causes drowning. And I don't think too many people are going to argue that people drowning causes other people to consume more ice cream, at least not on a statistically major basis. So the key factor here is there's something else going on. And if you stop and look at it and you start looking at the data, what you'll notice is in the summer, there's higher sales of ice cream, more deaths by drowning. In the winter, there are lower sales of ice cream, lower deaths by drowning. So those two things are correlated, but A doesn't cause B. All right, now, this is actually on page 7 of the notes, but I just put it in the second document to make it a little bit easier to jump here. There are actually 5 possible reasons why you could have a strong correlation. Now, number 1 is the direct cause and effect, where, A causes B. Number 2 is the flip side of that. You could have a reverse cause and effect where B actually causes A. Now, the third one is sort of where we were with the Australia example. Correlation caused by a third variable. Both are dependent on another independent lurking variable. Number 4 is kind of number 3 on steroids. You have a complex interrelationship. Maybe it's more than one variable at play that's driving both of the things you're looking at. And number 5, which is probably not quite as common as the first 4, I hope not, is it could be a coincidence.